Alex, make a distinction for us between a population parameter and a sample statistic. Maybe it's 15 questions. So obviously, you're stunned that I would ask something. Stunned means a scientist. You need to go home for dinner tonight and you've got to explain to your mother the distinction between a population parameter and a sample statistic. What do you think? He's not here, can't find you. Okay, so you quick flew home overnight. Or more generally, what's the difference between a parameter and a statistic? Yeah, and so is the statistic always the same? The construction is always done the same way, but the realization of the statistic changes depending on the basic difference we have said. Yeah. Does the population parameter? Yeah, so the population parameter is a number. Okay. We don't know what it is. As scholars, we're trying to figure it out. So the population parameter is immutable. There is no density function that describes it. It's always the same. It's hard to figure out what it is. The sample statistic is contingent on the particular sample that you got. Dave Baduri. Dave, give me an example of two events that are mutually exclusive. Heads and tails are mutually exclusive events. As long as you're on a roll, give me an example of events that are collectively exhaustive. Heads and tails again. So heads and tails are collectively exhaustive. If you have one coin and you're flipping it, heads and tails are mutually exclusive and collectively exhaustive. That listing, that tells you everything that can happen in the sample space. You can get a head or a tail. There's no other possibility. Let's see. Nicole, Eson. Nicole, explain to us the notion of intersection in probability and statistics. Are all of the econ graduate students in this class at present? Are all of the MSFE students in the program in this class at present? Yeah. Some of them are. There's a year of students ahead of you and a year behind you. So not everybody who's in the MSFE program is in here. Not everybody that's a graduate econ program is in here. There are some students that are beyond this, and there are some students who are not here yet. Done enough background. However, you guys are the intersection between the set of MSFE students and the set of all econ graduate students. So that would be the notion of intersection. So we have a sample space. This is a set of all students at the university. We have a set A that consists of the students participating in the MSFE program. And we have a set B, which is the students in the Econ PhD program. And in this room, there are some students taking this class, some from each program. So you guys are the intersection of the two programs. Hillary, explain to us the union of two sets. Yeah, so the union is the group of the students who are either in the MSAP program or the Econ PhD program, or both. Bob, pardon. What's conditional probability? What do we mean by conditional probability? Suppose that my Venn diagram there is dartboard. and I stood back here, and I had a couple of darts, and I'm really good at shooting darts. And I blindfold you, and I promise not to throw darts at you. I'm not the board every day. So you're blindfolded, and I throw the dart at the board, and I ask you, what's the probability that I hit A? How would you do that? And my dart lands with constant probability across the whole surface S, the whole box. So there's a uniform distribution of points that I hit when I throw my dart at S. And I ask, what's the probability that I land in A? How would you figure it out? Now you're blindfolded. All you heard was the whack when it hit the board. So I know it hit the board. Yeah. And you know it hit in the box somewhere. So now I'm asking what's the probability that I hit A? You could ask me questions like, what's the area of the box S squared? 5. And then you could ask me something like, what's the area of A? And I told you it's 0.7. I must warn you that when it comes to specific numbers, as an undergraduate, I took something, and I think I got a D. So when it comes to discussing specific numbers, I sometimes have trouble. So just give me a point second. So now you're still blindfolded, and I have another dart. And by no means am I Robert, you put you narrow and split the card in the arrow. Well, I'm not like that. So, but I can throw another dart, and you hear it go flat. And I tell you, sure enough, I got inside the box next. And I'll even tell you that it's in B. Now what's the probability that I hit A? What's the probability that I hit A? Given that you know I hit B. So given the knowledge that I landed in B, you revise the probability of A. The conditional probability allows us to revise things, to get some more information. And as Robert figured out, as we portrait him through things, he said that the probability of A given B is equal to the probability of the intersection, A intersection B, over the probability of B. And from that, we can derive the multiplication rule. The multiplication rule in probability says that the probability of A given B times the probability of B is equal to the intersection.